This is problem 4. A ladder leans against a smooth wall. It is uniform and has a weight of 10 newtons. Calculate all the forces acting on the ladder. Okay. Yeah, let's do the system schema again. It's a simple system schema right now. We have the ladder, we have the wall, and we have the floor. Thing about the floor though is that it is not smooth. As you can see, there are diagonal lines here to represent not smooth uh, floor, but a smooth wall. So what that implies is that there is friction between the ladder and the wall. So let's do that. And in particular, it's called static friction because there's no movement, but there's a friction. The other kind of friction force is kinetic friction, where there is movement and there is friction. Also, there is a normal force between the ladder and the floor, and the normal force is always acting perpendicular to the surface. That's why it's called the normal force, because normal in mathematics is perpendicular. The wall and the ladder, there is also a normal force. There is no friction force. How do I know that there is no friction force between the wall and the ladder? Because because the wall is smooth. The wall is smooth. And let's not forget the earth. The earth is acting on the floor and the wall. My nose is acting up again. F sub G, F sub G, and also it's acting on the ladder. This is just the weight of the ladder, so maybe we call that weight of the ladder. Now, there is only one object in our system, and that is the ladder. So apparently, all forces acting on that ladder are external forces. So let's do the free body diagram for the ladder. And actually, let's just do that directly in this wonderful drawing. We know that this object is tilted. Actually, I forgot something. I forgot what the angle is here. But that's not a problem because we have this right triangle forming. Like, isn't this your typical 3, 4, 5? So we now know that the ladder is 5. They're forming a right triangle, and 3 squared plus 4 squared is equal to 5 squared. So we now know that the ladder is 5. Oh, interesting. And we can always get the angle here if we want and if we think we need to do that. So the weight of the ladder is 10 newtons and it is uniform, so it must act here in the middle of the ladder. Okay, so that's the weight of the ladder. Actually, if you extend this down further, you will notice that it is it hits the 1.5 meter mark, or it's 1.5 meters away from the wall. Here we also have a normal force according to our system schema, and the normal force is always acting perpendicular. And that's why it's called normal force. Let's just call that normal force due to the wall. And here we have another normal force here due to the floor. Let's just call that normal force due to the floor. Floor, F and F. And it also says in our system schema that there is a static friction force. So which way is static friction going? Static friction is going to the left. And how do I know that? I know that to be the case because this ladder is trying to slide to the right, right? But since this problem is an equilibrium problem, so there must be a force countering that motion, and that force happens to be the static friction force. I think those are the only forces, 1, 2, 3, and 4. Calculate all the forces acting on the ladder. Okay. We do know that the summation of forces along y is 0, and that there are only two forces acting along the y. That's the weight of the ladder, negative j hat, plus the weight of, and plus the normal force due to the floor, and that is j hat. Cancel all the j's. That just implies that our normal force due to the floor is just equal to the weight of the ladder. So therefore, our normal force due to the floor is 10 newtons because the weight of the ladder is 10 newtons. So that's one of the forces. We have F and F. How about F is F? How do we do that? Well, I'm trying to figure out how to do that. Okay. So let's try to choose this as the axis of rotation. Because we don't know what FSF is, but we want to know what FNW is. Force, normal force due to the wall. So, see, conveniently we can make this part our axis so that the contribution of torques by FSF is 0. Let's do that. You know, there is something interesting here. Remember this formula, torque is R moment arm times F, and R moment arm is the perpendicular distance from the force. So we can use that. This is R moment arm is a perpendicular distance from the axis of rotation to the line of action of the force. So here's the line of action. I'm gonna do the line of action of the force right there. So the line of action of the force, you just draw dashed lines. So let's just see. Torque done by the weight of the ladder, torque done by the normal force due to the wall is equal to 0. The torque done by the weight of the ladder is it makes the object rotate clockwise. No, counterclockwise. So this is positive. And the normal force due to the wall is causing the ladder to rotate clockwise, so it's negative. So let's do R moment arm, weight of the ladder, times the weight of the ladder, minus R moment arm of F and W times F and W. Got so many subscripts. The moment arm of WL is just this side right here. This is the distance this is the perpendicular distance to the line of action of the force. And that's just 1.5. That's just half of the base of this triangle. So let's just do 1.5 meters. And the weight of the ladder is 10 newtons. This moment arm is right here. Isn't it? Isn't this the moment arm for this force? Because this is the one. is the distance that is perpendicular to the line of action of the force. And that distance happens to be 4, right? 4 meters. And F and W. Of course, you don't know what F and W is, but that's what we're about to find out. F and W, therefore, if you manipulate algebraically, you'll get 1.5 times 10 divided by 4, and you'll get 15 divided by 4. 3.75, and that's one of the other forces as well that we are looking for. So let's do a check, 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 and there is another 3.75, and that is actually FSF because the summation of forces along y equals 0. And there are only two forces along y, F and W, to the I hat. Oh, I am so sorry, that's along x. And Fs plus FSF negative I hat. And if you cancel all the I hats, you will get that FSF is just equal to F and W, which is equal to 3.75. There goes another 3.75. So what is this 10.7, 69.4 degrees? That is actually this force right here, the combination of F and FSF. And I don't know what you call that force. So that's that force that does rough wall, the rough floor acts on the ladder. That kind of force right there. It's just a combination of F and FSF. So maybe let's just call that FR. And don't ask me what R means, but FR is equal, the magnitude of FR is just FFSF squared plus FNF squared. And you'll get 10.7. At 69.4 degrees, you can use tangent theta. And that's the y component is FNF over FSF. And you will find that that theta is 69.4 degrees. Okay, finally we're done, and I hope that you learned some new things today. Thank you.